All right, so we're going to finish up our graphs of sine and cosine by looking at graphing multiple transformations. Okay? Anytime you do multiple things in the same problem, the order that you do it in, that is important. Okay? So here's the order we need to follow. And it's the same order that we've used all year. Always do your horizontal shifts first. After you do your horizontal shifting, then you do your horizontal stretching. Okay? Or it could be compressing, depends on the problem. Okay, after you do your period change, what would come next?
Your vertical shift.
No, not the shift. That's going to be last. Yeah, the stretch or the amplitude change. Okay, vertically stretching. And the last thing is your vertical shifts. Now, if you use the letters that I've been using as we went through the notes, I used A, B, C, and D. All right, so we had something like this. You could do this with sine or cosine, okay, but I'm just going to write it with sine. All right, so we got sine bx plus A. Let's put C in the front and D at the end. All right, so this is your phase shift, period change, vertical stretch or amplitude, and vertical shift. What are we going to be careful about with transformations 1 and 2? Yep.
Signs.
All right, what do you mean by the signs?
Like if it's positive and negative.
All right. So why do we have to be careful with that?
Because if it flips it. C on that.
Yeah, I'm going to get to C in a second. I agree. There is something we got to be careful with a negative with C.
Yeah.
We'll talk about that, but 1 and 2 we have to be careful with.
To do the opposite of what the signs goes. So negative, you usually go left, negative, you should go right.
Yeah, with the 1 and 2, anything that transforms the graph horizontally, it does the opposite of what you would think. Plus is going to move left, minus is going to move right. Big numbers for B are going to do what to the graph?
Small.
Make it smaller, compress it. Big numbers make it smaller. Small numbers make it bigger. Okay? With C and D, that's not true. Okay, you do exactly what you see. Bigger number makes the graph bigger for C. Positive shifts up for D. Negative would shift down. The last thing, what happens if C is a negative?
On the flip on the body.
Flip on
Y-axis.
which axis? The X. All right, so if C is negative, you could take a graph like that and turn it into that. It does a reflection over the X-axis. Okay, so those are our 4 steps. All right, so let's try this one. Okay, it says to graph 2 sine x plus pi over 2. Yep.
Is there one that flipped over the y-axis?
There is, but we didn't cover that. Okay, if b was negative, that's what would cause a flip over the y-axis. We've covered it with other graphs. We just didn't do it with trig functions. All right, so basically, however many transformations you have, that's how many tables you need to make. So we'll start with one transformation, make that table, and then we'll use that table to do the next one. All right, so what number do I want to focus on first here? The pi over 2. Okay, what kind of transformation is that? It's a phase shift. So what I'm going to do is pretend that this is the problem. I'm going to ignore the 2. I'll come back to that. I'm just going to do the phase shift first. Okay, so for a phase shift, what values stay the same? Y's. So 0, 1, 0, negative 1, 0. Okay, and what am I going to do to all my original x's? I'm going to subtract pi over 2. All All right, so if I do that, Shannon, what will my first one be?
Negative pi over 2.
Negative pi over 2. Okay, my second one?
0.
Yep, I got 0. Okay, the third one is pi minus pi over 2. What's that going to be?
1 pi over 2.
Yep, 1 pi over 2. How about 3 pi over 2 minus pi over 2?
2 pi over 2.
2 pi over 2, which becomes
Pi.
just pi. And what's 2 pi? Take away pi over 2.
3 pi over 2.
3 pi over 2. Yeah, you tend to start to see the pattern. It's the same numbers we originally had, except it starts at negative pi over 2 instead of 0. All right, so now we've shifted it. All right, now we got to do the final table, which is now going to do a, well, what is the 2 going to do?
Vertical stretch.
It's a vertical stretch. So when we're stretching vertically, what values are not going to change? The x's. Okay, if you're going to stretch vertically, you're going to change the height. That's your y values. So now copy your x's, not from your original table that we had on Monday, but from the table we just made. Okay, so these are my x's. 0, pi over 2, pi, 3 pi over 2. And what am I going to do to all of my y values?
Multiply by 2.
Yeah, we're going to multiply them by 2.
So we're taking the x from the first graph.
Yes. Yep. Don't go back to the original x's, because if you do that, you're going to get rid of the phase shift you just did. Okay, so we did the phase shift first. We didn't have a period change, so we didn't have to worry about that. And now we're doing our vertical stretch. So 0, 2, 0, negative 2, 0. Okay, on the test, that's the only table that I'm going to grade. The final answers.
So what, you just subtract pi over 2 from each one, or you?
I subtracted pi over 2 from each x.
For the second one.
I doubled all the y's. Right? 0, 2, yep. Just doubled every y value. Hey, any questions on that table? And now the last part, graph it just like we always do. So we have 0, 2, negative 2. For my x's, let's see. I'm going to put negative pi over 2, 0, pi over 2, pi, 3 pi over 2.
Isn't that wrong? Because don't you have to space it out because you went over the y-axis?
Yep, but I am going to use 0. Okay, I didn't skip 0. That's actually going to be a point on my graph. So if you're using 0 as a point on your graph, then you don't need to skip. Okay? If 0 was not a point on my graph and I skipped to the next one, then I would have to skip every time. Okay? So, but if you use 0, don't worry about skipping. All right, so now we get negative pi over 2. We're at 0. And you'll know when you draw your points. If you do all your points and like one of them looks like this, like really squished, something here, this point looks too close, we know we did something wrong. Okay, they all have to be spaced evenly. All right, so 0, 2, pi over 2, 0, negative 2, back to 0. Okay, any questions on that? So that's x, that's y. Okay, I think it can be a little hard to see my axes, but I tried to make those slightly darker, a thicker line. But I'll label them too so you can see my axes. Okay, so any question on that one? All right, let's try this one, but you know what? Let me add one thing. put a +4 at the end. All right, so how many tables are we going to make this time? Yeah, we're going to make 3. Okay. My first table is going to deal with which number up there? The 2x, yep, 2. Okay, so we'll make the table for 2x, and then we'll use that to make our next table. Okay, Dalton, what is the 2 doing to the graph? Yeah, it's going to be a stretch. Is it going to affect my x's or my y's? It's going to affect the x's. So keep the y's the same for now. They're going to change later on, but we'll do that after. And Derek, what am I doing to all my x's?
Divided by 2.
We're going to divide them by 2. Okay? Or you could also say, what's another way to say it?
Multiply by half.
Same thing, yep. Divide them by 2 or multiply by 1/2. Okay, so my first x is 0. That's going to stay at 0. What's my next x value? Yep, the original is pi over 2, and then we got to, as Derek said, divide by 2. Pi over 4. Next one? Pi over 2.
3 pi over 4.
3 pi over 4. And pi. Good. Good. Any questions on that? All right. Now, and this is where the order becomes very important. Which one do I do next? The 3 or the 4? The 3. Okay, the vertical stretch. If you don't, it will come out wrong at this point. Okay. Since we're going to stretch vertically, now I'm going to change my y values. Okay, vertical are your y's. In fact, the x's are done changing for this whole problem. Okay, we're not going to do anything more to the x's. So you get 0, pi over 4, pi over 2, pi over 4, and pi. Right. Nick, what do I do to all these y values? So what number are we working with that's going to affect the y values now? Not the 2. The 3. You said divide by 3?
Yeah.
No, you're not going to divide by 3. Anyone help them out? What do we do? Yeah? Multiply by 3. Okay, this is going to make the graph 3 times as tall. Okay, so we get 3, 0, negative 3, 0, 3. All right, so now we've done the period change. We've done the vertical stretch. Fernando, what's the last thing I need to do? What's that? Yeah, the +4. And what kind of transformation is that? That's a vertical shift. Okay, since it's vertical, the x's are going to stay the same. So I'll just copy those. And my y values, what am I going to do to all my y's? Yep, you tell me what they'd be, Yopi?
7. Maybe
7.
0.
No, it was 0. It's got to change. 4.
1.
1.
4.
7. And there's our graph. Well, there's our table. All right, so on my axes, I've got to go, let's see, all the way up to 7. All right, so what I might want to do is go by, I could go by 2s, but I think I'm going to need another line in here. So put one here, put one here. Let's go want to make those two lines a little thinner. And let's see. You know what? I'll just sketch them in. That's easier. All right, so we're going to start at 0. And what do we say? Go by, yeah, 2s or 3s, that's fine. So 2, 4, 6. Okay, and 7, it's just going to be a little bit higher. Okay, my x-axis, I'm just going to go by my labels right there. 0, pi over 4, pi over 2, 3 pi over 4, and pi. All right, so we got 0. So my x line would be about there. My nice graph paper. Let's see, 0, 7. So it would be 0, 7. Okay, yep, pi over 4, we're at 4. Pi over 2 at about 1. And then we're going back up. Back to 4. Back to 7. Okay. So now just connect them, and there's my graph. Okay, so on the test, you won't have one any more complicated than 3 transformations in the same problem. Okay. Now, what would have happened if we switched the order that we did this one and this one? What would this first y value have become? So I think if you added 4 first and then tripled it, it would have become 15. Okay, if you added 4, it would have been 5. And then tripling 5, you get 15. That's not the same thing. All right? So basically, the order matters when you're doing 2 transformation on the same axis. Okay. This first one, that affected the x's. The 2 affected the y's. So technically, since those are separate transformations, the order you do these in doesn't really matter. I would stick with the order I always give you, so then you don't have to worry, does the order matter, does it not matter? Just use that order all the time. Okay. And let's finish up our graphing with this one. Okay. Is the order going to matter here? Do we have 2 transformations that are affecting the same? They're both horizontal. So yes, the order does matter. Okay, but it's just 2. We're not going to do 3. Okay, which transformation do I do first? The pi over 2. Okay, that's a phase shift of sine. I think we did plus pi over 2, so this one's just the other way. This is minus pi over 2. Okay, so what do I do to all my x values?
Times by 2. Oh, plus pi over 3.
Plus pi over 2. Yep, that's a phase shift. Okay, so you're adding pi over 2. Okay, so what will my new x's be? Brendan, give me my first one.
First one will just be pi.
Yep, pi over 2. Okay, second one. Pi. Yep, next one. 3 pi over 2. 3 pi over 2. Okay. 2 pi. And 5 pi over 2. Okay, so hopefully we're getting a little bit more comfortable adding and subtracting pi over 2 and just starting to notice the pattern rather than having to go through common denominators every time. But any questions on the x's? Okay, so now our y's are going to stay the same. Cheryl, can you remind me, what are my y's for sine?
They're 0, 1, 0, -1.
All right, so we got our y's. And now my last step is to deal with the 3. Okay, Tyler, what's that 3 going to do?
Well, it's gonna change the period.
Yeah, it's going to change the period. All right, so that's again going to affect my x's. All right, so just copy down your y's. Don't have to worry about changing those. And what am I going to do to all my x values? Yep, multiply by 1/3, which is the same as dividing them by 3. Okay, so my first x value will become,
Pi over
so we're going to take pi over 2. What are we going to do to it?
2. Pi over 6.
We're going to multiply by 1/3. Okay, so that's pi over 6. Questions on that? Right, how about the next one?
Over 3.
Pi over 3. Good. How about third one?
Pi over 2. Pi over 5.
So it's 3 pi over 6,
Pi over 2.
which is pi over 2. Okay, 2 pi becomes
2 pi over 3.
2 pi over 3. And the last one?
5.
5 pi over 6. Doesn't look like these are equally spaced, but that's because all your denominators are different. If you had common denominators, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So it's a nice pattern. Okay. Any question on the table? All right, now our graph. I'm going to just space out my x-axis using those values. We just saw they're nicely spaced. Okay, so we got pi over 6, pi over 3, pi over 2, 2 pi over 3, and 5 pi over 6. If you did this in degrees, you'd see that this is 30, 60, 90, 120, 150. It's basically going by 30 degrees. Okay, and we got to go up to 1. Right, so 0, 1, 0, negative 1, 0. And 0 starts at pi over 6. So 0, 1, 0, negative 1, back to 0. Okay, so any questions on graphing sine and cosine, either using a single transformation or putting multiple ones in the same problem? All right, so last thing from this section is really going to focus on using the calculator. Okay, so we'll practice finding some windows, graphing on there, and then doing a little bit of equation solving. All right, so this problem is asking us to graph 4 sine 3x, so just on the calculator, not by hand. And then after we graph it, we want domain, range, period, and amplitude.
What do you do when
What's that, Tyler? Hold on. Dalton.
What do you do when there are no parentheses?
When there are no parentheses? All right, so let's make sure people know. What's the 3 here?
Like what do you
That's what? What is that 3 going to do?
X.
That's a period change. And what about the 4? That's a vertical stretch. Okay? So anytime you're multiplying, that's always your stretches. Anytime you're adding or subtracting, that's always your shifting. Okay? Inside in the function, you can put parentheses or you can leave them off. It doesn't matter in this problem. Okay? Where it would matter is if I had something after it. If I want that 2 to be a phase shift, I need to go like that. If I want it to be a vertical shift, I need to leave those off. Okay? And you might have one in the homework tonight that's a graph like this. So you'd be subtracting 2 from all the x's. There's no nice way to write that. So you might just have things like pi over 2 minus 2, pi minus 2, 3 pi over 2 minus 2. All right? It's a little messy, and you'll have to just label your axes with those numbers. That's it's a messy phase shift. That's all it is. Okay? But you still do it the same way. All right, so let's graph that and see if we can figure out what they're asking for. All right, so we got 4 sine 3x. Right, I'm going to do zoom 7. That just gives me a rough sketch. All right, and let's start with the domain. What's the domain of that function?
I think it's 7 both ways. Positive.
So I can't plug in any numbers.
It's negative infinity.
Right, you can plug in anything you want for x. With sine and cosine, they are continuous functions. They go left and right forever. Okay, so the domain is, you could write all reals. Or I'll write it the way Kyle said, negative infinity to infinity. Okay, my range. Well, we can either look at the graph or just look at the equation. Think of what your range would be normally for sine, but then you're doing that 4 to it. So what's my range going to be here?
4 and -4.
Yeah, -4 to 4. Okay, normally it would be -1 to 1, but you're quadrupling it. So instead of -1 to 1, you can see on the graph, it's -4 to +4. Okay, any questions on the range? Right, what about my amplitude?
Same thing. Or would it be
Well, the range is an interval. The amplitude is just a single number.
4?
In this case, amplitude is just 4.
What do you mean by in this case? It's just.
What's that?
You said in this case it's 4.
Yeah, in all cases, the amplitude is just a single number.
Okay.
Yep. Range is always an interval between two
So the
numbers.
amp is the same as the range, just like the.
It's the highest y value and the lowest y value. That's the range. Right, and what about my period? Does anyone remember that equation? It starts out with a t. Yep.
T equals 2 pi over 4.
2 pi over
3.
3. Okay, 2 pi over 3. Okay, any questions on that? Right, now what if I put a +1 on the end? What would that do?
Vertical shift and whatnot.
That would shift it up 1. Would that affect the domain? No. Would that affect the amplitude? No. Would that affect the period?
Yeah.
Shifting it up 1?
No.
No. The only thing it would affect is the range. Okay? If you shifted everything up 1, what would my new range be? Yeah, if you moved everything up 1, just think of this window at -4 to 4, push everything up 1. -3 to 5.
Wouldn't that change amplitude?
Nope, the amplitude would still be 4. Yeah, because the amplitude is, remember, it's just the height off that center line. So if you shift everything up, the center line shifts up with that. Think of it there. So it's still the same distance. Yep. All right. All right, so this one asks us to find a complete graph and then again do the same thing. Domain, range, period, and amplitude. Okay, what's my domain here? Yeah, for sine and cosine, it's always -infinity to infinity. Okay, what about my range? -3 to +3. Yep. And it does include them because you will hit those values. Okay, what about my period? 2 pi over 1. There's no change in the period in this problem. And my amplitude, 3. So let's graph that and see what we got. 3 sine x minus 1. Okay, so there's our graph. And what we do is if they want to know what window you used, just write down your x min, your x max, your y min, and your y max. Okay, that's the window we used. Okay, and you could just do -8 to 8. That's fine. Basically, and same on the y-axis, you did -4 to 4. You could get away with -3 to 3, although your graph would be right on the edge of the screen. Okay, any questions on that? All right, so the other thing we can do on the calculator is solve equations like this. For now, we'll practice it on the calculator, but eventually we're also going to practice solving these by hand. Okay. All right, so let's just graph this. Okay. How could I set this up so I can graph it? Where would I type in sine of x, and where would I type in 0.4?
Sine of x would be on like y1.
Okay, we can put sine of x on y1, 0.4 on y2, and just do zoom 7. Okay, before I show you the picture, how many solutions do you think this would have? Okay, pretend like you were looking at the entire picture. 5? So this is going to be a wave. This is going to be a horizontal line. Yeah, there would be. Yeah, there's infinitely many solutions, unless they tell you to narrow down where you're looking, okay? Which in this problem they do. All right, so I'm taking a look at my window the way it is right now, but they want me to narrow down where I look to be between 0 and 2 pi. So what would these two values be in my window? Where would I type them in? Yeah, for my x values. Okay, x min and x max.
So how would you punch that in the y section? Like, yeah.
Just sine of x in y1 and 0.4 in y2. All right, and for your window, make sure you adjust it to what they said to. Okay, and when we solve trig equations, there's going to be a couple ways we do it. Sometimes they're going to tell you a window and want you to narrow down where you look. Tomorrow they're going to say, you know what? We don't just want to know those two solutions. We want to know every solution, forever, all the solutions. So there's a way we can write it. All right, but we'll talk more about that tomorrow. Okay, for today, we're just going to find this one and that one. All right, so how do I do that? Yep, second, calc, intersect. Okay, I'm in radians. Okay, so my answers are going to be in radians. If you're in degrees, just change it to radians and do zoom 7 again, and it'll look just like this.
We change that.
Degrees and radians is under mode. All right, since there's 2 intersection points, I got to be closer to the one I want to find. Okay, so the first one is about 0.41.
What'd you type in for your window?
I did zoom 7, but then I adjusted the x min and the x max to these two values that they gave me,
0 and 2 pi.
0 and 2 pi. Yep. Okay, so my second one,
What did you get for the first one?
0.41.
Okay.
Okay, the second one is about 2.73. Now, how often are these answers going to repeat? All right, that's how many times they're going to repeat, infinitely many, but how often would they occur? Like, exactly, it's going to repeat every period, okay? So you're going to get this answer repeating every period. So if the period here is 2 pi, it's going to be here. The next one is going to be 2 pi units later, and the next one, 2 pi after that, and it's going to keep repeating every 2 pi. And the second one is also going to repeat every 2 pi. All right, so tomorrow we'll talk about how we'd write that. But the first step in writing that is just to figure out these two. Okay, so any questions on just getting those two answers? All right, this one's pretty similar. Again, they're telling us where to look. So it says 2 cosine 1/2 x equals 1.5. Okay, so let's type that in. I'm just going to type 1/2 that way. It's a little easier. And 1.5. If I didn't put this 2 in front of the cosine, what's the highest and the lowest cosine would normally go? 1 and -1. So if cosine only went between 1 and -1, and I asked where it hits 1.5, what would be the solution? You wouldn't be one. You'd have a graph that looks like this. It would never hit it. But because I put that 2 in, it's going to now go 2 to -2. It's going to make the amplitude taller. So it is going to hit it. All right, so let's see where it hits it. Okay, we already know it's going to hit infinitely many times, but for today we're not interested in that. All we're interested in is finding the solutions where they tell us. Okay, I'm going to make sure my window is still 0 to 2 pi. And how many solutions do I get here? Just one. Second calc, intersect.
What's your window on
I did zoom 7 and then change my x min to 0 and my x max to 2 pi. 1.45. What one number could I change in y1 to increase the number of solutions I get? All right, what do you want to change the 2 to? 1/2? Well, actually, I wasn't thinking of this, but yes, you technically answered my question. I said, how could we change the number of solutions we get? You definitely just changed it. We get none now. All right, so that does answer my question. What's another way we could change it so we get a ton of solutions? Changing that won't, let's see, will that give us more? So it's going to make it really tall, but it actually still only gives us one solution.
What if you change
The 0.5. What could I make the 0.5?
like more bigger?
Bigger, yeah. If you make that really big, what does it do to the graph?
It compresses it.
It compresses it. So now it's going to go up and down a lot in that little section. And now I'm going to get a bunch of answers. Okay. I wouldn't give you one where you had to write 10 answers in one problem. But I'm just trying to make sure you guys understand changing the numbers, what it does to the graph. Okay, compressing and all that stuff. Okay. Questions on that one? And last two. All right, so this one we can do a couple different ways. Okay, let's do it the way we've been doing it. Type in one side on y1, type the other side on y2, and we're between 0 and 2 pi. Okay, I'm still between 0 and 2 pi. Let's hit graph and see what we get. Okay, how many times does it look like those graphs cross? If you can't see it, I'll make it bigger. Yeah, it looks like they're going to cross 3 times. Here, here, and here. And we're looking for the x value of where they cross each time. All right, so now we just have to find all 3. So second calc intersect. All right, so first one is 1.70. Okay, the next one, let's see. We already have it. What is it?
Yeah, 3.14.
3.14. So my guess is that's probably at pi. Okay, but don't worry about changing it to pi. And if they're symmetrically spaced, I'm going to guess the difference between 1.7 and 3.14 is going to be the difference here. All right, do we have the last one?
5.26.
5.26.
2.3.
2.3. Okay. So you just got to do second calc intersect 3 times. Now, that's one way to do it. All right, so doing it this way. Actually, you know what? I want this screen. Yep. All right, so doing it this way, we used second calc intersect. What's another way I could type this whole thing in on y1? Let's say I didn't want to use y2. Think about
You have to go to math.
that original problem. What else could I do to rearrange this first and then type it in? Well, let's look at second calc. The other option we could use is on the screen. What other option do you think I could use? I could use 0. Yep. How could I use 0? What would I have to do to this first? Make it what? Yeah, we'd have to make this equation equal to 0. Right? So how could I take and put this on the other side? What would I do? Yeah.
Divide by that, right?
No, we wouldn't divide by it.
Negative.
We'd subtract it. Yeah. Okay, so if we subtracted it, okay, which I'm just going to type quickly like this. I'm going to take 3 cosine 0.5x, which is y1, and I'm going to subtract 2 sine x, which is y2. I could retype it all in, but that's just a little faster. Okay, I'm going to shut off that and shut off that. Okay, so now what I'm going to do is graph it, setting it equal to 0, and I'm going to look at how many times it crosses the x-axis. Right, notice it crosses how many times? 3, and it's going to be in exactly the 3 spots we just got answers before. Okay, I'll just do the second one. So calculating 0, and we get 3.14, which is exactly what we got. So the advantage of doing it this way is you actually see a combined picture of what these two graphs look like together, rather than looking at 2 separate graphs. Right? And if we zoom out, or not zoom in, sorry, zoom out, you'd start to see there is a pattern to it, but it's not quite the same sine and cosine wave we're used to. Okay? Kind of dips down, goes up, looks flat, dips down, goes up, looks kind of flat. It's not completely flat, but that's our picture. All right, so when we start combining trig functions together, there's still a pattern on the screen, but not quite the same pattern we're used to. So any question on doing it either way? Okay, let me put the second way up there. Let me see if I can. Sometimes I can't grab it when this is, I don't like it when it's blinking and it blocks out the number. Sometimes I get lucky. All right, so if you do it this way, second, calc, 0. Okay. Or graph both on separate y1 and y2 and calculate the intercept. All right, so I will not show you on the day of the test how to do that. Okay, so if you have questions, you can ask me up until then, and we'll go over it. All right, so last problem is an inequality. This time, I don't want to know where they cross. I want to know where one is above the other. So our answer usually isn't a single number, like x equals 3.14. What kind of answer do we usually get with inequalities? A what?
A single number.
Well, when you're solving an equation, you get a single number. Brendan?
Do you have a range?
Yeah, we get a range of numbers, maybe everything between 2 and 6, or whatever the range is. So we're going to get an interval. Okay? Maybe even 2 intervals. Maybe it goes above for a while, maybe it goes back down, and then maybe it goes above again. Okay, let's see what it looks like. Right, so we got 2 cosine x, negative 1.3. And I want to know where the graph in blue, just underline these, that's in blue, that's in red. And they want to know from 0 to 2 pi. Okay, my window is not at 0 to 2 pi because I zoomed out. So I'm going to start with zoom 7. Okay, and then what I'm going to do is go back to window and do 0 to 2 pi. All right, so where is the blue graph above the red graph? Okay, what's my first step? What do I have to do? Yeah, I got to see at least where they cross. Okay, so I know the y value here is negative 1.3 because that's what we're intersecting. What I need is the x value. Anybody have the 2.27? Thank you. Okay, and I need it for this one as well. So I got negative 1.3 for the y. How about for the x?
I got 4.004.
4.004? Okay. Anybody else get that? Okay, so let's just go 4. That would round down. 4.00. All right, so how many intervals are there where the blue is above the red? Amanda?
Two?
Two. There's two separate intervals where the blue is above the red, one interval where it's below. They want to know where it's greater, where it's above. All right. Anybody give me the first interval where the blue is above the red? From what up to what?
0 to 2.27.
Yep, I like the 0 to 2.27. Can you just tell me, Dalton, what kind of symbols on these?
I have a bracket on the 0 and let's see.
Bracket on the 0, because we can include it. But we want to be strictly greater. So on the 2.27, that's where they're equal. So don't include it. Okay. And does anyone remember the symbol we put in between when we have two intervals? Yep. A U. So or. And who can give me my second interval? Yep.
Parenthesis 4.00 and 2 bracket on it.
So 4.00, I like that. Parenthesis, because we can't be equal. And up to what number?
2 pi.
Yep, we're ending at 2 pi. Bracket or parenthesis?
Bracket.
Well, can we include 2 pi?
No.
No. Okay, we can't include 2 pi, we can only be less than it. So we need a parenthesis. Okay, and if they wanted the interval where the blue is below, it would just be between 2.27 and 4. Okay. Okay, any questions on that? All right, so as I said, tomorrow we'll finish up with the other graphs we haven't done, and we'll do a little bit more calculator stuff like this. All right, so the homework is on 346 tonight and tomorrow. It's in the book. 2 through 4, 7 through 9, 15, 17, 21 to 23, 29 to 31, and 36 and 39. Okay, some of the graphing ones here are a little messy. Okay, the numbers don't come out nice. So if that's happening, don't think you're doing it wrong. That's just the way the numbers work out.